as matter is neither created or destroyed during a chemical reaction the total mass before is equal to the total mass after. What do we call the material after the reaction? Products, because they are produced. So the only thing that happens in a chemical reaction is bonds are broken, new ones are formed, so they just become rearranged. The atoms become rearranged. As, that should be as, not. Where's my eraser? So, because each atom has mass, we must balance chemical equations to follow this law. Usually you leave hydrogen and oxygen to the last. They should be the last two elements that you ever balance with. And depending on which one is by itself, if you've got H2 or O2, that is definitely the very last element you're going to balance, because it's going to be the easiest one to balance if it's just by itself. So if we're going to do this, Braden says, I've got 3 carbons here, so I need 3 carbons on the right-hand side. So now carbon is balanced. What would you do next?
Balance hydrogen.
Balance hydrogen. On the left, we've got 8. On the right, we've got 2.
4.
4 what?
4 H2O.
4 H2Os. Now, on the right-hand side, we've got 2 times 3 and 4 times 1 oxygens for a total of 10. We only have one place where oxygen is here, and there's 2 of them, so you take the total on the right, divide by that number, and that will tell you how many. 5 oxygens. Okay. What do we call those numbers up there in red? They have an actual term. Begins with the letter C. Yes. Coefficients are whole numbers used to balance equations. So they have to be whole numbers, because you can't have half of a molecule. So if you were reading this out loud, if we were balancing this equation and somebody had to give me the answer, you would state 1, 5, 3, 4, but you don't have to write 1. But you can't say none. If there was none, it wouldn't be there. There's no sodium in this equation. All right. When you add a solution, AQ is your subscript, of sodium sulfate to a solution of barium chloride, subscript is AQ. That means I've dissolved some solid sodium sulfate in water to make a solution. I will end up with a precipitate, solid barium sulfate, and a solution of sodium chloride. So NaCl is AQ. Where do you think you would start?
Sodium.
Sodium. Sodium's a great place to start. If there's metals in your equation, they're usually the best place to start. So if we balance for sodium, what are we going to do? Diamond?
Would be 2 NaCl.
We would need a coefficient of 2 for sodium chloride. I'm going to give you a hint because some of your questions are going to be a little more complicated than this. When you are balancing, treat sulfate like it's one entity. Don't break it down into sulfur and oxygen because there's one on each side, so that part is balanced. Because if you have something a little more complicated than a 1-to-2 ratio, you're going to be keeping track of a massive amount of oxygen atoms. So, if you have a polyatomic ion that stays a polyatomic ion in your equation, treat it like it's one entity. Yeah?
We're good.
We're good for this? Sure? What do you think, Matt? Yeah? We're good. You think you're okay? Want one more?
Yes.
Do this one. And I'll show you a trick. How many people are done? How many people are struggling with this one a little bit? Okay. My suggestion to you when you do these is you do them in pencil. In case you want to erase stuff. Or that's if you're the kind of person that doesn't like messy. If you don't mind being messy, like me, just if you're going to do it in pen, don't be worried about crossing something out, putting a new number above it. Because it just shows you work. What's that? You know what? The more information I can gather, the better I know you as a learner. The better decisions I can make. Okay. How many people are done now? So about maybe a quarter of the class. Okay. Miss Thatch, where do you think you should start? What do you gravitate towards? What's your gut? Where did you start? I'm not asking if you're right or wrong. I'm just going to ask you where you would start. You're going to start with a C? Okay. How many carbons on the left? 4. So how many do you need on the right? 4. Watch this. I'm going to make a mess. Okay, so this is a good place to start. How about the hydrogens, though? How many do we have on the left? 10. So how many would we need on the right? So we've only got one place, though, with hydrogens. And you can't rearrange a formula. So we would need, right? Are we okay up to this point? This is where we have a problem. This is where a lot of you are getting stuck. And I'll tell you a little trick. This is going to be needed to be balanced, but you're always going to end up with an even number. Because whatever number it is, you multiply it by 2. Therefore, on the right-hand side, you're also going to have to end up with an even number. You've got an even number here, but an odd number in your water. So when you look at these kinds of equations and you end up with an odd number of water, go back to your carbon compound and double it. So I want you to do that right now. If you haven't finished this equation, go back and now make this 2, which gives us how many carbons do we need on the right? 8. Now we've got 8 carbons. How many hydrogens are we going to need now? We've got 2 times 10, so 20. So we're going to have to multiply that one by 10. Now balance for oxygen. Okay, now balance for oxygen. We got a whole whack of them. And guess what? The coefficient here is now going to be odd, and that's okay. How many? Do you agree? What number did you get? 13. And then this is 13. So if you end up with an odd number of waters, and it's just a hydrocarbon, what 2 elements are in a hydrocarbon? hydrogen and carbon. A hydrocarbon contains only hydrogen and carbon. So if you have a hydrocarbon and you end up with an odd number of waters, go back, double your initial compound, okay? It's a good trick to know.